This is another application for TimeWise library. In this application, we want to show the flexibility the TimeWise can provide to the users. Once the users have the data, they can set up different gates or even multiple gates. This application is written in MATLAB. It is on the time domain set VSWR measurement. The time domain set VSWR approach is a EMC chamber validation approach according to C63.25.1. For this method, we have two antennas in the chamber. The transmit antenna is on the quiet zone. The receive antenna is at a certain distance away from the quiet zone. And we collect S21 data. Once we have the S21 data, we apply a bandpass gate to only include the direct antenna-to-antenna response, and we call it gate-in data. And then we apply a notch gate to notch out the antenna direct response, and we call it gate-out data. So the gate-out data over the gate-in data is the reflection coefficient. And then we can use this reflection coefficient to calculate the set VSWR of the chamber. So the lower the set VSWR is, the better performance the chamber has. Okay, so let's load a data set. So here, this figure shows the raw data in time domain, which is the black line. Let's zoom in a little bit. We use the global maximum in time domain as a gate center, and let's set the gate width to be 4 nanoseconds, and we choose gate shape as normal, and edge treatment technique as renorm, and we gate the data. So this red curve is the gate-in data in time domain. And in frequency domain, the black line is the raw data, and the red line is a gate-in data, which is the antenna-to-antenna direct response. This chart shows a notch gate to notch out the antenna-to-antenna direct response. We call it gate-out data in time domain. And this red curve is the gate-out data in frequency domain. So this is the reflections. So now we have the reflections and the antenna direct response. So we can calculate the reflection coefficient, and as a result, we can calculate VSWR, the voltage standing wave ratio of this chamber, which is this red line. Okay, so now it looks like the set VSWR of this chamber is more than 20 dB, which means this chamber performance is not good at all. There are major reflections in this chamber. Okay, so now we want to find how to improve the chamber. Okay, so this black line here is the data after applying the first notch gating. And now we can see in this data, we still have a peak, which is pretty significant. We think that is a big reflection in the chamber, so we apply a second gate to notch out this time impulse. And we also use a normal gate shape and the renorm gate edge treatment. And this is how it looks like in frequency domain. And now, after apply a second notch gate to notch out these big reflections, we can calculate the chamber set VSWR performance again, which is the black line. It shows after notching out the second peak, the chamber performance is improved by a lot. So then we need to, based on the time of the second peak, to find the reflection source of this second peak. Then we can improve the chamber performance. So this application really shows the flexibility of the TimeWise. We can apply different type of gates. We can change the gating parameters. And also we can apply a second gate to notch out the reflection to debug the chamber.